IT, or information technology, it's a modern phrase, isn't it? It's not something that we find written in the Bible, nor would we expect it to. However, the information which we see in the scriptures would lead us to infer that actually divine IT, or information technology, is actually embedded within the words of the page and the message it conveys. So we'll have a brief discussion upon what information is, the nature of it, which is important, how information is used. And then once we look at DNA, genetic information, look at modern science and information, and finally we'll come to our conclusion regarding divine IT. What is IT then? What's the definition? Well, we find here one definition: it's the study or use of systems, especially computers and telecommunications, for storing, retrieving and sending information. Now, I'm sure the younger generation know all about information technology, but the older ones amongst us might not understand particularly what it is, so we put that definition there. It's the study or use of systems for presenting information. Okay. And what is information? Well, it's facts, provided or learned about something or somebody. Okay, the bottom line says it's from the Oxford English Dictionary as a definition, so we'll see how we go. The information needs to be communicated, doesn't it? How are we going to get the information from the sender to the receiver? Well, there's various types. We can do what we're doing now, the spoken word. The written word, we've got the printed page before us, haven't we? We've got video and we've got electronic behind us after a fashion. All means of communication, aren't there? But there are others, not so modern ones. We have the Egyptian hieroglyphics. For many years, people have looked at these symbols and signs and thought it was just merely wallpaper, very attractive, but it didn't really do an awful lot. But Napoleon's army, one of his soldiers, actually discovered the Rosetta Stone, and from looking at that, they unlocked the mystery, if you like, of the Egyptian code. Just the bottom few lines there, it says that the Egyptian language, the study of the Rosetta Stone, laid the foundations for our knowledge of the ancient language and culture. So we can see, actually, information technology is quite old, because back in early times, the Egyptians were using the hieroglyphics. But later on, we've got the invention of the Morse code, whereby beeps and signals were transferred across telecommunications, and messages were sent from one person to another, particularly across the Atlantic. So that was quite a modern innovation for transmission of information. And again, when we're on board ships, you've got no electrics, but by the means of flags and that, we can get messages sent from one ship to another. In the modern Navy, we've got all the technology we could even think of. But back in the olden times, when all they had was boats and people and flags, then messages could be sent, information could be put across. But coming more recently up to date, you may have noticed when we're on trains, we have signals now, different coloured signals, where the signals that are up or down will instruct the drivers of the engines of the trains to either stop or go or wait for further information. So we see various methods used. And we're familiar tonight if you came in a car this evening, you would no doubt you'd have passed through traffic signals. So again, it's all different mechanisms for transferring information. And computers, when they work, are very good. We have the binary code. When we punch information on our keyboard, it transfers the information from the keyboard into information that the computer, the processor behind, can understand, a series of ones and zeros. And the various combinations of those give various messages and signals to the computer, which then transfers it back to our screen, and we can see, hopefully, a lot of information. So that's the different forms of information, but there's one common theme throughout all this information process. There's a sender, isn't there? Whether it's by Morse code, whether it's by the Egyptians in their hieroglyphics, there's a sender. And there's always a code involved, be it the English language, be it computer code, be it the semaphore code, there's always a code involved. And then it's delivered. The communication is delivered, isn't it? But the other person receiving it also has to understand the code. And then he can receive the message, he can unpack it and receive the message. And that process is common throughout all things. Let's give it to really elaborate that point. let's assume we have a traffic engineer, and he wants to control the traffic. So we come through a traffic system, which we did in rugby. We might come through the gyratory system, or other such things like that. What will he do? He'll use the code. I'm not talking about the design code for designing the roads. This is purely a code for the road user. Okay? What will he use? He'll use the highway code. Okay? How will he deliver that message? Well, road signs, or particularly, he'll use traffic signals. Yeah. It's a means, again, of communicating the message from the engineer to the people on the road. But it's incumbent upon those in the cars or the vehicles that they also understand the highway code, isn't it? So again, they receive the signals, understand the code, and the receiver, then the car user, the traffic will be controlled. Okay? And that's true for all information, isn't it? That we can see. If you get it wrong, though, well, what will happen? Well, you'll get a traffic jam, won't you? So the information, it's important that it gets transmitted, but it's also got to be received as well. So there's intelligence involved in all of these systems, isn't it, is what we're trying to say. Is this sentence above here that we're going to put on now, is that information? Well, it's not really, is it? It's just a jumble of letters. So far we're getting it. What about the next line? Is that information? Well, we can see familiar patterns developing there, can't we, within the lines behind us there. But it's not really information yet, is it? No. If we put spaces, if we put some syntax or some grammar to the sentence, it opens it up now. We can see a pattern forming now. It still doesn't quite give us the information we need, but it's getting there. So it's not really information as yet, because you're not getting the full message that I'm trying to communicate. And the message is that information is always systematically arranged. Okay? Now, these are basics, but I want to establish some basics. When we look later, we'll see why it's so important to understand these things. This is what information is, isn't it? It's a systematic arrangement of information. Now, it's been said, if you had a chimpanzee, you put him in a typewriter, and you give him long enough, he will type the whole works of Shakespeare, or certainly a part of it. But it doesn't actually work like that, because it's not just getting the letters to form words. It's not just getting words into sequence and patterns with spaces. It's also getting punctuation. And there's terms of meaning and phrases within the language, isn't there? So it's never going to happen just by chance. There's always a systematic arrangement. And we see that there's one common denominator. That an intelligent source is always involved, without exception. Without exception, everything we see around us, there is an intelligent source that's designed the information. We know this by our own experience. And some science have led it to this to be a law of information. Information can only come from an intelligent source. It's not created randomly. The information source is not dependent upon the medium which it's transferred. The words on the page don't just happen. They're organised, in the case of a book, by a typesetter that has put the words in order. So the medium involved is not important. It's the message it's carrying. And that's important because if we have matter, we can't just grow things. We can't grow books. We can't just let things form by natural processes. That will give us the medium, but the information that's put upon it, how it's transferred, is the key. And that's always done by an intelligent source. Now I want to look then at DNA. Deoxyribonucleic acid, as you see the Oxford Dictionary tells us, it's a self-replicating material which is present in nearly all living organisms as the main constituent of chromosomes. It is the carrier of genetic information. So we're getting closer to home, if you like, right within our bodies. Now, it's not going to be a biology lesson because I'm not capable of doing that, but I just want to convey some basic messages. That it was thought 150 years ago that the cells in our body were very simple, and that it'd be quite easy to understand that from a simple cell we could grow many different complex organisms, and just by various processes of mutation we could get this change, or this development. But modern science has shown us that even the simplest of cell is not simple. And within the cell nucleus, we see there, we've got the chromosomes, and within that we've got the familiar double spiral helix there, and that contains the genetic code and the information. Now, these things, this is just the nucleus of the cell. We could multiply that, we get the rest of the part of the cell with all the other matter that we need to build the body. But what does DNA actually do? Well, I want to focus on just particularly one thing for a moment, that's on proteins. DNA contains the information to make amino acids, which in themselves come together in special combinations to form different proteins. And what do the proteins do? Well, they're used to make the body, to skin tissue, to bone, nails, hair, etc., structural things within the body. They also transport about substances around the body. They also have protective uses. They carry antibodies around the body as well. They also dissolve other matter such as sugars to give us energy and so on. That's just a very brief outline of what it does. But it's the amount of information that's required to make all these things to make the body. So the body is not simple. And more importantly, or as importantly, the information that's contained in the cell is passed on to future generations. So information within our bodies, we call it hereditary characteristics, don't we? Pass on to our children, our children's children. So it's the means of replicating ourselves is built into this genetic code. I think we've got most of the words on there. What we can see then, the genetic code is a code, a system. When we look, we see the rungs of this spiral staircase, if you like. It's made up of different molecules, adenine, thymine, guanine, cytosine. We don't need to know what they do, but scientists have discovered that if we put the first letter of each molecule, it actually does read a code. And that code then gives different instructions throughout the full length of the spiral of the DNA. So it's already pre-programmed in there. So how do you make a protein then? Well, molecular biologists have discovered that we'll actually have machines within the cells that do various tasks. So we've got that's the nucleus of the cell where the DNA is stored there. Enzymes will come in, they'll split the helix apart, it uncovers the information. They'll unwind the helix, so it pulls one side out in a long strand, as you can see going off the screen there, or that side there. Okay, but it's got all the code on there. Okay, another enzyme will then copy that code and then take it and transport it outside of the nucleus. Then another enzyme will come in and seal the helix back together again and put it back together, ready for the next sequence. And this way, cells are developed and multiplied to eventually get the whole body as it develops. Just to make it a bit more simple, I'll put it in more of a process diagram, if you like. Imagine the enzyme as a factory worker, okay? And inside the factory, or the nucleus of the cell, the DNA code's there. The enzymes will go in and will take certain parts of the code. It's got a certain job to do. In this case, we're going to look at making proteins, okay? It takes the code, we said, it copies it. It's also got a spell checker to check for errors when it's copied as well. Okay, so it's a whole process that goes through there. Once it has the information then, it's transported out of the nucleus. Okay, so it comes outside then to be transported to the ribosome, or really it is a factory. The factory process, whereby then this information then, it's taken and the enzymes will go off and they'll go and find all the other molecules that make up the amino acids. And it goes out and it searches, depending on the code, it's like a shopping list. It goes out and it finds all the information and then it's joined together. We said there's up to 20 amino acids make a protein. So we can see how complex this is. This isn't just happening, randomly. There's a sequence of events that go on. But it doesn't end there. For the protein to form, the amino acids are not only organised in a certain manner, they're also folded into a particular shape as well. So we see it's quite specific, isn't it? And then the proteins they go off into the body and do the various bits, be it building the rest of the body or other systems. But again, don't look at the detail of the slide and what it's meaning. Just want to notice that the amino acids have come together to form the protein there. And what it needs to bond with is other parts of the body, in this case to produce sugars, glucose and fructose. But just look at the shape of the protein, how it needs to be, that it needs to find the sugars, and they've got a certain shape as well. So, and it's not just a 2D shape, it's a 3D shape. So these amino acids have to be brought together and formed in a specific shape as well. You can see the amount of detail that's involved. It's incredible, isn't it? It's absolutely incredible. We could go to a modern factory and we see the same thing happening, but this is not in a factory, this is within the cells of the human body. So we see then, it's not only complex, it's very compact as well. Just some interesting facts that I got from the internet. Our entire DNA sequence, all the information that's strung out, the whole package is called the genome. You might have heard of the Genome Project, trying to understand all the code within the human cells. It's estimated that there's 3 billion different rungs, if you like, on the ladder within the DNA code. An awful lot of information. It's been estimated that that information could be stored on 3 gigabytes of storage space. If you understand computers or USB sticks that Stuart's got down there, that's not an awful lot of storage space to put this kind of information. And in fact, a DVD movie would only take 1 gigabyte. So all this marvellous stuff, just by an analogy, you could see it's in a quite compact space. And some have said if you unwound all the DNA material and put it together, the width of that strand of information would be 50 trillionths of an inch wide. That's pretty thin, isn't it? And if you took all that information out of all the chromosomes, strung it together, it says that you could reach the moon 6,000 times. I'll take their word for that. I don't know if that's true or not, but nonetheless, these are scientists who are providing this information. So we can see it's incredibly complex and incredibly compact what's being organised here. Now, this has caused a problem for certain modern scientists who believe, really, it's going back to the Victorian times when science was all about matter and energy, the two entities. It's matter and energy, and it's the interaction of those things whereby we can take simple things and bigger things will come from that by the interaction of the physical or the chemical properties. There's an action or reaction or an attraction, and they felt that's how life would come about, or different forms of life would come about, if you like, right from the very start. And it's a very materialistic viewpoint. As we said, that's how evolution of life, or the species that we find now, different forms have come about. This is the classical, the Darwinian model, which basically hasn't changed that much. That given random chance process and involving long periods of time, that the molecules will eventually grow, they'll be attracted together, and they would form all these proteins, amino acids, just by a physical attraction together. And then by a series of mutations in those cells, then we get the various things. So we go from a fish to a lion, and so on, from a simple to the not so simple, the complex. But a lot of scientists are actually questioning that themselves now, because when they've looked, they've seen, well, random chance, they've discounted that because what we've seen is so specific that it needs to be carried out. The mathematical chance of it happening just by a random process is virtually statistically zero. So that's been discounted. What about if you had enough time? Well, if you believe that the Earth was around for 20 billion years, mathematically you still haven't got enough time for this to happen. So the scientists have discounted that as well. What about the process of attraction? That these amino acids can just be attracted to each other just naturally by their chemical attraction. Well, we see it doesn't happen like that. First we need the DNA, then the instructions go out to find the various amino acids, then it comes together, then they've got to be put in a certain order, and then they've got to be folded. So you just can't have an attraction. There's a whole process that goes on. It's a fabrication process, isn't it? And the scientists will tell us that mutations actually, they don't increase information within the cell, it actually destroys information. So if you get destructing the information, what are you going to build? Something that's not really very fully functioning. It doesn't create things that are more complex later down the line. It actually destroys the information. So what you're getting now is a substandard product, if you like, which is what the humans are at the moment, to put it bluntly. But what else have they found then? Well, regarding information, many scientists now have said, look, there's actually a third entity now. We've got matter and energy, but we've got information. And that's an important step. And many scientists are questioning, well, the whole theory of Darwin's evolution, that we go from a simple to the complex. We've seen from the DNA, you need the information in the first place before it can have any changes to take place. So where does the information come from, is what many scientists are now questioning. And these are non-religious, unbiased. And so we have a whole movement called the intelligent design movement that come out. They haven't gone to say, well, we believe it's God doing that, but the model that we have before us, we see we can't believe that. We've seen that there is intelligent source involved there. And that's what we saw earlier, didn't we? That information always comes from an intelligent source. We know it to be true. We see it every day. It's a provable experiment which we do ourselves, isn't it? And it should be no different when we come to the DNA, the information there. So where did the information come from then? Well, we said earlier that it's not written in the scriptures, but we believe it's inferred. If you turn back to Genesis 1, if you would, for a few moments. Where is it inferred then, this information process that we've seen? Well, there's a phrase there that you've no doubt noticed as we've gone through, that when God created things, he said, he created it after his kind, whose seed is in itself. Verse 11 and 12. God said, let the earth bring forth grass, the herb yielding seed, and the fruit tree yielding fruit, after his kind, whose seed is in itself upon the earth, and it was so. And the earth brought forth the grass. So we've got the grass, we've got the plants, we've got those living things. Okay, when we go to verse 21, we move on then into the sea and to the air. That God created great whales and every living creature that moveth, which the waters brought forth abundantly, after their kind, and every winged fowl after his kind. And God saw that it was good. And God blessed them, saying, be fruitful and multiply and fill the waters of the earth. In the seas, rather. So, we're seeing a pattern developing, aren't we? We've gone from the plants, we've gone from the whales and the fishes in the sea, we've gone from the birds, and now we come to land. And again, the same thing is written there, isn't it? And God said, let the earth bring forth a living creature after his kind, cattle and creeping thing, and beasts of the earth after his kind. And it was so. When we look at the Hebrew word, when it says kind, it means a sort or a species. So what we see from the scriptures point of view is that each plant form, each animal form, insect form, is its own individual species or groups. Okay, so humans want to bring humans, birds want to bring birds, and so on and so forth. And the Bible's quite clear on that. So what do we see then? That each of these elements, each of these animals, these plants, they have the ability to replicate. What's the information to replicate? Well, we've seen it, it's in the DNA, isn't it? To prove all these things. And we come to mankind, don't we? It's the same process within us. We found the DNA, we've got the instructions to build ourselves and to replicate ourselves. Whose seed is in itself is another way of saying, God saying, that we have the DNA information within ourselves to produce men and women, dogs and cats, horses, and all the things on it. Whose seed is in itself is another way of saying it's got the DNA in itself. Now, the Bible's not a science book, and if God did put all the chemical formulas in here, the book would be this big, and who could understand it? The book's not a book of science, but nonetheless we get little glimpses of what's going on. There's a few interesting quotes, I think, here. Bill Gates, in his book The Road Ahead, said, the human DNA is like a computer program, but far, far more advanced than any software ever created. And he's quoted a few pieces of software himself. In fact, we're using his software tonight in the PowerPoint slide. There's the analogy there, the computer program and the DNA is very similar, but the DNA is more advanced. And Richard Dawkins, we don't often use his quotations in a good sense, but nonetheless he makes an interesting point. He said, the machine code of the genes is uncannily computer-like. Apart from differences in jargon, the pages of a molecular biology journal might be interchanged with those of a computer engineering journal, because it's the same processes that are going on. There's programs going on, there's spell checkers and all that kind of thing, much more technical than I'm producing tonight, but it's the same idea, isn't it? Now, we shouldn't find that surprising, should we really? Because if these things are remarkably similar, it's no coincidence. Mankind has created these programs which the scientists tell us and others that it's remarkably like DNA. Well, if God's made an image and likeness of man, then it's not surprising then that what he's producing, he'd be thinking on the same wavelength, the same process that God has. The DNA, God's created, the computer programs, a very similar process. Now, man could have created something completely different, but he hasn't. And why has he gone down this route? It's just the simplest way of getting a lot of information transferred very quickly. And you can replicate it, you can make it as big or as small as you want. Lots of information are contained. And I believe that it's, like I say, it's no coincidence. Daniel, in his book written many years before Christ, 2,000 years indeed before us, he said that before the time of the end, when the Lord Jesus Christ will return, there should be an increase of knowledge. In fact, the word increase there really means to multiply. And what have we seen in the last 50, 60 years? The information and knowledge is absolutely multiplied astronomically compared to, say, times that have gone past. So this has been fulfilled. For a final reference, would you turn to Romans chapter 1? Because although when the Apostle Paul wrote this, he didn't have the understanding of the genetic biology that we can have. And that's one of the good things about the internet. We can get this kind of information that can help us understand the world in which we live. But Paul, when he writes in chapter 1, he's speaking about those that are contrary to God, that are not doing what God wants. But he just gives these few words here, and I've got the North American Standard Bible quotation there as well. But we'll just read from the King James for a moment. He says, "Because that which may be known of God is manifest in them, for God hath showed it them. For the invisible things of him from the creation of the world are clearly seen, being understood by the things that are made, even his eternal power and Godhead, so that they are without excuse." And that was, nearly 2,000 years ago. And Paul saying, if you look around you, the things that are created, it's obvious there's a designer. But when we move to our times now, we're looking at the really, the absolute minutiae of cells, we can see that this quotation here has a lot more power for us, doesn't it? Because that which is known about God, we've looked at the DNA, it's evident, it's within them, literally is within us, isn't it? And for since the creation of the world, his invisible attributes, we can now see. The microscopic, we can see that, to the eye, they're invisible. But with the advancement of science, we can see the invisible. And what do scientists see when they go down further and further to the nucleus of the cell? They see order, they see information, they see a factory process going on. It's astounding and astonishing. And so the Apostle Paul can say, and we can say now, that we are without excuse. Science has shown us all these wonderful things, and I believe it leads us to the mind of God. So in conclusion, what have we seen? Well, I think we've seen that divine IT and science is a witness to God. There's many debates that say, science versus creation, but you can't have science without God, because he created everything in the first place, and he's created the physical arrangement that we can do science. So it's not the case of science versus creation. It's creation will be seen in science, if you like. We can look at prophecy, other lectures we've had, look at the nation of Israel, archaeology, numerology, the list goes on, doesn't it? What we've seen tonight is just one strand, one proof, if you like, or witness to God and his creation. But the whole point is, isn't it, is that God's created the earth not in vain. He created it to be inhabited by people that will wonder at his creation and his glory, and will seek to follow after him, because there's a wonderful prize. The prize is the kingdom of God. When, God willing, all the things that we don't understand now, we can ask God, the angels that created all these things, how did you do that? How does that DNA work? And other such things. Thank you for listening.